Okay, so, it seems like everyone and their mother is making AI chips now. Google's got their TPUs.
Yeah.
Amazon's doing Trainium.
Right.
But NVIDIA is still like the 800-pound gorilla in the room.
Yeah.
Like, why is that?
Yeah, that's the big question.
You sent me a bunch of articles on this.
I did.
And I'm ready to kind of get to the bottom of this with you.
Awesome. Yeah. It's a really interesting topic, and it really kind of gets at the heart of how AI is evolving.
Right.
Because you would think that these companies would want to be using their own hardware.
Right.
But it turns out NVIDIA has got a really strong hold on things for a few reasons.
Okay, so before we get into the why of all that, can you kind of paint a picture for our listener of just how much NVIDIA is like baked into these cloud platforms that we all use?
Yeah, absolutely. So like just think about Google Cloud, for example.
Okay.
If you're using Vertex AI, which is their machine learning platform, guess what's powering those workflows behind the scenes?
NVIDIA
GPUs, yeah.
Okay.
Or if you're, using Dataproc to like crunch massive data sets, using tools like Apache Spark.
Okay.
Chances are you're leveraging NVIDIA's processing power there too.
So it's not just like a little niche thing. It's like woven into the fabric of these services.
It's pervasive, yeah.
Yeah.
And it's a similar story over on AWS.
Okay.
Those EC2 instances that everybody uses for training AI models, often running on NVIDIA GPUs.
Yeah.
Even their forays into generative AI tools, things like that, and even edge computing, with NVIDIA's Jetson platform.
Yeah.
It really shows you just how much they rely on this technology.
Yeah, it's pretty remarkable considering how much Google and Amazon are investing in their own custom chips.
Yeah.
Like, it makes you wonder, like, what's the point of TPUs and Trainium if NVIDIA is already kind of everywhere? So what makes them so special that they're even trying to compete?
Yeah. Well, that's where things get really interesting because both TPUs and Trainium bring some unique advantages to the table.
Okay.
Let's start with Google's TPUs.
Okay.
These things are purpose-built for the kind of math that underpins deep learning.
Okay.
So things like matrix multiplications and tensor operations.
Okay. So without getting too technical for our listener here, like, what does that specialized architecture actually translate to in the real world?
Yeah, so basically, imagine you're trying to train a massive AI model that needs to analyze millions of images or process huge amounts of text. TPUs can crunch through that data significantly faster and more efficiently than a general-purpose GPU.
Wow.
We're talking potential time savings of days, even weeks, depending on the task.
Yeah, so in a world where speed is everything,
Right.
it sounds like TPUs could be a real game changer.
Yeah, potentially huge.
And one of the articles even mentioned that Google had to like redesign
Yeah, isn't that crazy?
their data centers to handle the cooling demands of their latest PPU v4 chips. That's a statement.
It tells you how serious they are about this technology. They're not just dipping their toes in the water.
Yeah.
They're building the infrastructure to support AI at a massive scale.
Yeah. I mean, that's huge.
Yeah.
So, but I imagine there were some downsides to being so specialized, right?
Oh, of course.
Yeah. Like you can't...
The biggest hurdle for TPUs right now is accessibility.
Oh.
You can pretty much only use them through Google Cloud. And the software ecosystem that supports TPUs isn't as mature as NVIDIA's CUDA platform, which has been the industry standard for years.
So they might be the speed demons for certain tasks, but they don't really have the reach.
Exactly.
It's like having a super fast race car.
Yeah.
Amazing on the track, but you can't really drive it to work.
Right. Not so practical for everyday driving.
Yeah. Yeah. And that's a good segue, I think, into Amazon's Trainium chips, which are kind of taking a different approach. Like Trainium is kind of like the more affordable, practical option in this race.
Yeah. Think of it as the, the value option.
Yeah, exactly.
But still a good option.
Right. And they're really targeting, it seems like, the training and deployment of large language models.
Huge area right now.
Which is huge right now with ChatGPT and all that.
Absolutely. Everybody wants to build the next viral chatbot.
Right. Exactly. So this is AWS's way of saying, hey, we can help you get there without breaking the bank.
Exactly. And they're not just competing on price either.
Okay.
Trainium 2, their latest generation, is reportedly 4 times faster than its predecessor.
Okay.
So, to put that in a perspective, that means you could potentially train a large language model in days instead of weeks.
That's huge.
Saving you both time and money.
So they're making some serious performance strides.
Absolutely.
But I'm guessing there are some trade-offs there, too?
Oh, of course.
Especially since it's a relatively new technology.
It is, yeah. I mean, Trainium is still in its early stages.
Okay.
You know, the software ecosystem is still developing, and it's not as widely adopted as NVIDIA's offerings.
Right.
It's a promising contender.
Sure.
But it still has a lot to prove.
Okay, so it sounds like both TPUs and Trainium have the potential to, shake things up a little bit.
Yeah.
But they're facing some pretty big challenges.
Right.
Which brings us back to our original question.
Yeah.
Why is NVIDIA still holding on so tightly to the crown? Like, what's the secret sauce?
Yeah, well, there are a few key factors at play.
Okay.
And they all speak to, the complex dynamics of the AI industry.
Uh-huh.
It's not just about the chips themselves.
Right.
It's the entire ecosystem that surrounds them.
Okay, I'm ready to unpack that. So let's dive into those key factors when we come back.
Sounds good.
Okay, so we're back, and we're going to try to figure out why NVIDIA is still the top dog, even with all these other folks trying to come for the crown.
Yeah.
You were about to tell us about their secret sauce.
Yeah, well, one of the biggest factors is NVIDIA's software platform, CUDA.
Okay.
It's become like the industry standard for programming GPUs.
So you're saying like most developers are just used to using CUDA?
Yeah, it's almost like the Windows of AI development.
Okay.
It's just what everybody uses.
Right. And so switching to something new is like a nightmare.
Yeah, imagine you've spent years learning a specific programming language, building your whole workflow around it.
Right.
And then somebody comes along and says, hey,
you got to start over.
You got to switch to this new thing.
Yeah.
You're going to have to relearn everything.
All right.
Potentially rewrite tons of code.
Yeah.
Deal with all sorts of compatibility headaches.
So even if TPUs or Trainium are better for some things, the hassle of switching is just not worth it.
For a lot of developers, it's just not worth it.
Yeah. Okay. So CUDA is a big one.
Huge. Yeah.
But I know from the articles also, NVIDIA's versatility is a big advantage.
Oh, absolutely.
Can you unpack that a little bit for us?
Yeah, sure. So while TPUs and Trainium are designed specifically for deep learning, NVIDIA GPUs can handle a much wider range of tasks.
Yeah.
They can power everything from high-end gaming to complex scientific simulations.
Right.
Even those virtual workstations that Google offers.
So it's kind of like the Swiss Army knife of chips.
Yeah, I like that.
Like good for all kinds of things.
Yeah, you can use it for all sorts of stuff, not just AI.
Right, and so that makes them like a safe bet for companies.
Right, exactly.
Because they can use it for...
It simplifies things from a procurement and management perspective.
Right, okay. And then there's also the fact that NVIDIA has just been the top dog for so long.
Yeah.
Like everybody uses them because everybody uses them.
Exactly. It's like that popular restaurant that everybody goes to because everybody else is already there.
Right, exactly. And so they have more developers.
Right. It's a chicken and egg thing because they're so widely used. Yeah. They attract more developers.
Right.
More software gets built for their platform.
Makes them even more attractive.
Which in turn makes them even more attractive to new users.
Yeah. It's a tough cycle to break.
Very tough cycle to break.
Yeah. So NVIDIA has this trifecta, CUDA, versatility, and just that staying power.
Yeah, that incumbent power.
Yeah. But what about the future?
Right.
TPUs and Trainium just going to be playing catch-up forever?
Well, not necessarily.
Okay.
Remember, technology is constantly evolving.
Right.
What's dominant today might be old news tomorrow.
Okay.
There are a few trends, I think, that could really shake things up in the AI chip landscape.
Okay, I'm all ears. Give me the crystal ball predictions.
All right, so for one, I think we can expect to see even more competition entering the market.
Okay.
It's not just Google and Amazon anymore. We're seeing startups, chip manufacturers, even other tech giants jumping on the AI chip bandwagon.
So more players.
Yeah.
Which hopefully is good for innovation.
Absolutely.
And maybe good for our wallets.
And hopefully lower prices.
Yeah. Okay, what else?
Another interesting trend is specialization.
Okay.
So as AI models become more sophisticated and targeted towards specific tasks, we might start to see chips being designed for very specific purposes.
Oh, okay.
Imagine a chip that's optimized for generating realistic images, or another one that excels at natural language processing.
So instead of that Swiss Army knife, we have a whole toolbox.
Exactly, a whole toolbox.
Of specialized chips.
Yeah.
Okay, interesting.
It's all about efficiency and performance. If you can build a chip that's perfectly tailored to a specific task, it's going to outperform a more general purpose chip.
That makes sense.
And as the demand for different types of AI applications grows, this specialization could become even more pronounced.
So what about the big cloud providers like Google and Amazon?
Yeah.
How do they fit into all this?
Well, I think we'll see a move towards what you might call a hybrid approach.
Okay.
Instead of betting on just one type of chip, cloud providers might start to offer a more diverse menu of options, allowing customers to choose the best chip for their specific needs.
So it's less about brand loyalty and more about picking the right tool.
Exactly, the right tool for the job.
Yeah.
Some workloads might be best suited for NVIDIA GPUs, while others might benefit from the specialized power of TPUs or the cost-effectiveness of Trainium.
So more choices for developers.
Right, more choices for developers and companies who need that flexibility to optimize their AI workflows.
Okay, so here's something that I thought was really interesting in the articles. One of them pointed out that as AI keeps evolving, the cost of actually using a trained AI model, like they call it inference, is going to become more expensive than the cost of training it in the first place.
Yeah, that's a really important point.
Wait, hold on. Break that down for me.
Okay.
What is inference and why is it getting so expensive?
Okay, so think of it this way. Training an AI model is like teaching a student all the information they need for a test. Inference is like the student actually taking the test and applying that knowledge in the AI world. Inference is what happens when you use a trained model to make predictions, generate content, or perform some other action.
Okay, so why is that getting so expensive?
Well, as AI models become more complex and capable, they require more computational resources to run.
So all those like really realistic deep fakes that we see and those chatbots that can like almost hold a conversation with you.
Yeah, all that stuff.
That's all inference.
That's all inference, and it takes a lot of processing power to make that work.
So it's not just about training the model anymore.
Right.
It's about making sure that you can actually use it.
Exactly, and that it can be used efficiently and affordably.
And so that could have a huge impact on
yeah,
which chips people want to use.
Yeah, chips that are optimized for inference might become even more valuable than those that excel at training.
Wow. This is really interesting stuff.
It is. It's a very dynamic field.
Yeah, it sounds like the future is very much up in the air.
Yeah, the future is unwritten.
Yeah. But it's going to be a fun ride.
It's going to be an exciting ride for sure.
That's a good way to put it.
Yeah.
Okay, so let's shift gears a little bit and talk about what this means for our listener and why they should even care about any of this.
Sounds good.
Okay, so we've talked about all these different chips and all these trends, but like, why should our listener even care about all of this?
Right. Well, it might seem like just a battle between tech giants. Something that's happening
in Silicon Valley
boardrooms. Yeah. But the truth is this chip war has implications for everyone.
Okay.
Because these chips are powering the AI revolution.
Right.
And AI is changing the world.
So even if we're not all, AI engineers or data scientists, this stuff's going to affect us.
Absolutely. It already is.
Yeah.
Think about all the AI-powered tools you use every day.
Like what?
Things like your voice assistant, recommendation engines on, shopping websites, and even just like spam filters that keep your inbox clean.
Okay.
All of those things are powered by AI. And AI relies on these chips to function.
So these chips are kind of like the invisible engines driving the AI revolution.
I like that. Yeah, that's a good way to put it.
So how does all this competition actually benefit me, the average person?
Well, competition is always a good thing for consumers.
Okay.
It drives innovation, it pushes prices down, and it forces companies to create better products.
Right.
So in this case, the more competition there is in the AI chip market, the more accessible and affordable AI is going to become for everyone.
So it's kind of like this trickle down.
Yeah, ripple effect. Yeah. This battle at the top ends up benefiting everyone.
Good, more choices, better performance.
Exactly.
Lower costs.
Lower costs.
Right.
And it's not just about the chips themselves either.
Oh.
This competition also drives advancements in software development tools, the entire AI ecosystem.
So it's like...
It's a rising tide that lifts all boats.
Yeah, I like that. Okay, but can you give me like a concrete example of how this is going to affect my life?
Okay, so imagine a world where personalized medicine is really available, where AI can help doctors diagnose diseases earlier and more accurately, or picture self-driving cars that are actually safe and reliable, you know, transforming the way we commute and travel. These are just a couple examples of how AI could revolutionize our lives. And the chips that power these systems are at the heart of it all.
Yeah, so it's not just like some futuristic thing. It's like happening now.
It's happening now, and it's going to have a real impact on our lives.
So for our listener out there who wants to, you know, stay ahead of the curve, what should they be paying attention to?
Just be curious. You know, read about the latest advancements. Pay attention to which companies are making big bets. And don't be afraid to experiment with new AI-powered tools and services.
Okay, so keep learning and keep exploring.
Absolutely. The AI landscape is constantly changing.
Yeah, this is a lot of good information.
It is.
So it's not just, you know, a tech race. These things can actually change the world.
Yeah. I mean, these chips, they're going to influence everything.
It's crazy to think about.
From healthcare to transportation to entertainment.
Yeah. Well, that's it for our deep dive today.
Great.
Hope you enjoyed it.
I did.
And we'll see you next time.
Sounds good.